This is the Fender Deluxe Reverb, model AB763. This is the black face, the older one. What a wonderful amp to have to work on as compared to the previous non-documented amp. This amp is just filled with all sorts of documentation. Just to talk about it really quickly, a couple things we're going to do. I have to be really careful about this one. Because of what it is, we can't just simply start ripping stuff out and throwing stuff in. I have to be really careful about it. I have the parts that were removed from this amp from the previous work. I'm actually be testing those and looking at them. I'm already in agreement with the person who did the previous work, just based on what he had removed. I'm going to test them anyway. This amp has intermittent failure with the sound. Apparently, I'm told a crackling. This gets worse over time. Chris was electrocuted at one of the terminals with the amp off. Leans towards possible capacitor issue. I did see that the fuse was burned on the inspection of the fuse in my initial inspection of this amplifier, and yet I found that the fuse that was in there was also half an amp underrated, as 1.5 instead of 2. So this is going to be done very gingerly. We're going to go through the amp. We're going to do my regular tour of the amp. This is just an introduction, non-technical introduction of this amp. It supports all sorts of wonderful things, including it's got a reverb tank on the bottom of it, and has all sorts of wonderful features that we're gonna get involved with. But this is the next project. This is the Deluxe Reverb. So let's get started and start exploring. Here's the back of the unit. I should point out that the only thing I've done to the back of the unit at this time is remove the C-clamps that hold the power cable and the signal wires for the reverb. I have removed those clamps already and put them back in. That I have done, nothing else. Everything in here seems extremely original. Very nice indeed, very nice indeed. We have our speaker connector here. Like I said, this is reverb, this is power. A couple things I noticed immediately: the fuse connector is loose. Not the piece that goes on top, but the entire socket assembly is loose. Another thing I noticed is this 6V6. This was immediately noticed. This 6V6 is fully seated, and it is off kilter, and this is indicative of a problem in the socket, some sort of heat issue, or what have you. We're definitely gonna have to look at that. That is definitely not good. All the other tubes seem to seat fine, though you can never tell when the metal cover is over them. There is a bit of a rock to some of them. That gives me some cause for concern. We're going to go through very thoroughly and take a look. Speaker appears to be original. I believe there may have been a plate over this. I'm not a speaker aficionado. For those playing at home, however, this is 12 Kilo 5-6 465 it looks like 613. So the original covers are here. I did obviously take the top cover off. The bottom cover's here. The tube chart is in good condition. The reverb tank is down here in the bag, and the bag is securely seated into the bottom of the unit. We're going to look in further detail. We're going to take some of this off here. Let's see a bit of oxidation here, and I don't know quite exactly what that is. We're going to explore that a bit further. It's time to crack this amp open and have a look deeper. Also, I see here the model number, or the chassis number, is Alpha 17595. This also includes, by the way, a ground hum switch on this amplifier and a non-grounded auxiliary hookup right here. External speaker, I believe this to be 8 ohm. Standby, and I would imagine that the standby is for the plate voltage, for the DC plate voltage, so it would not pass any. And vibrato and reverb pedal, we do have the pedals for that. I've removed them from the chassis here. So a little tour behind the amp. I know the speaker works because this is the shop amplifier. And this uses the 5AR4 GZ34 rectifier tube. So awesome, awesome indeed. 6V6s. Don't know exactly what tubes are what in here. Like I said, there is a chart right here that breaks them out. You know what they do. I haven't looked yet. I just started looking at the diagram, and it's really nice. It tells a lot, so we're going to go through that. This is some more observation work. As we turn over the amplifier, we have a look below, right? And I did go through and look at all of these capacitors. That little black one there doesn't count, right? That were removed. And just to show you where they were, first of all, the big ones are part of the filter, and you will not see them on the bottom here. I just wanted to point out these are filter caps, right? And these right here, these are your 2525s, and they were replaced by these two. So it used to sit in, well, it used to sit in like that, you know, right there. So one over there, and one over there, and one over there. And that were these 25x2s. And then there was a single one right here that used to sit here. And all of them have been replaced, which I personally would recommend. So I'm not going to fault the guy for doing it. And when I did the testing on it, and I checked the leakage, they didn't pass at 2 milliamps of leakage. I think I got it in my book here. You know, I took some readings. They didn't look good at 2 milliamps. The 2 milliamps is absolutely unacceptable. I was just being nice, you know, so they were garbage. And I said, okay, fine. So they should have been replaced. But what I don't understand is that the last person literally ripped all them out. Judging by the amount of filter caps in here, all the filter caps are replaced. Except for that one. And that one's still in there. The significance of which is not readily understood yet. I'm going to look at the schematic. I'm just looking now, not touching, not modifying or anything. But I just thought it was weird that all those caps was shotgun replacement of these capacitors and just leave one in there. Okay. Look at this, and this fuse connection is just the nut in the back. We're just going to tighten that, and that'll be it. We're not going to worry about that. The other thing is I'd complained about this 6V6, and it turns out that it may just be that resistor was mounted way too low. That resistor may require an adjustment, and it's pushing out that connection. I'll have a closer look at it before I make any determination. Like I said, we're going to work very gingerly on this amp. We're not going to make any modifications that aren't absolutely imperative. And it looks like these are the original molded caps right here. And we're going to be calling in each one individually. So if they're good, we're going to leave them. If they're not good, we're going to call them in. I'm going to take some measurements on the board. We're going to do some ESR readings in position. We're going to make sure everything's copacetic. As little modification as possible, right? So this is going to be an exercise in patience. But you can see that the ones that were replaced, because they were replaced, were the dry electrolytics, and they were replaced by the Spragues here. So I already know what type of model was employed, so that when we look at the filter caps, when I flip this over, we'll try and ascertain what model is being used, so we could appropriately replace this Mallory here, because its day is done. And then once we look at it, once we rip it out of here, you know, then we could start, you know, torture testing it on there and see what it's made of, and see how it could be affecting the circuit. And, you know, once I address all these issues, and we're going to definitely check out the bias network over here. We're going to check out that, see back there is that diode, make sure that diode is healthy. Check out the voltages, and then let it run. We'll probably set up a fail, no fail test on here. Make sure that voltages are stable for a good long time. Do some heat measurements, things like that, and make sure that the gremlins are gone with the littlest amount of work, which is the antithesis of what I usually do on these amplifiers. I'll admit that I am a bit surprised to find these. I was probably expecting some of the blue Spragues to be in the filter caps, and that I found this in the box, this 100 microfarad 100 volt, and that one not done. I'm wondering, and I'm going to check to see, because of where it is located, if there is the possibility that there was a upgrade warranted for a particular circuit, and that this option was purchased and not installed, I'm going to do a consultation and see if that's the case. So I'm gonna ask around and see if that 50 was recommended to be upgraded to 100, and if so, you know, since we're removing and saving the originals, and find out that that's the case, okay. If not, I'll get a 50/50 and put it in. I'll get a sprig, and that'll be it. But this is obviously, this has been completely recapped. The board is a bit, you know, over the years it gets a little, you know, it's not flat, but it does what it's supposed to do, and it's covered with the safety can, obviously, or it could do terrible things. We're going to check those resistors, though, of course, because that those supply our voltages. Those I believe those drop. If you look on the schematic, A and B and C right there for some of our plate voltages. So those are definitely important areas to check, as with every other area. Another thing worth mentioning is this transformer here. I believe this is the output transformer, is loose. See that? We definitely have to tighten that down. So this will be fixed. And the reason why these tubes do not sit flush, and I don't know why that is because the socket is just designed. It has a rise in the middle of the socket, so if you push the tube in any direction, so I'll demonstrate here, it'll go off kilter to one side or another side. But they weren't meant to have a spring-loaded mechanism sit on top of it to hold it flush in there. So no worries with that. That's absolutely fine. Still going to look at this socket, fix this, close this up after we test those, and that'll be it. And we'll do that investigation. No sooner do we test our first 10K voltage dropping resistor, do we find out that it is in fact garbage. More than 30% out of spec. This one will have to be removed. While I got the camera rolling, let's check the other one. That'll probably be at least slightly out of spec or more. Usually problems tend to follow. And that is just over 10% out of spec. So they are silver band. So yeah, no good. The more I stare at the finals on this amplifier, the more things are starting to not add up. Previously, I had spoken about a tube that had not been able to sit properly. It was a 6v6 here. And if we look right here at the this suppressor grid resistor, the 470, we see that it is clearly not original, or this one's not original, or that one's not, who knows. One of them is not original. This one is twice the size as this one. And maybe I'm wrong, and maybe it's just me, and maybe I don't know what I'm talking about. But I do know that one is much bigger than the other. And I'm going to have to start looking at the way it was soldered in to see if this is an aftermarket solder job here. And look at this right here and see if this is actually original Fender. Because the work that was done on here is such that the tube doesn't sit in the socket. And I'm going to have to check this resistor down here too. I wonder if these resistors got so hot that they started to melt. I'm going to put a bar in and see if they're actually true anymore. Sometimes you can see a bit of a bend in the resistor itself will let you know. Probably saw an awful amount of heat, especially if the bias was off, especially if that was off. But this will be interesting, and it'll also be kind of nice if the whole problem resides simply in this portion of the circuit here. Because I don't think it sits in the power supply filtering per se, because all that was replaced. And I looked at the job, and from what I saw, the error lies in the fact that the plate voltages would obviously actually be lower with the problem that I saw with the resistors. So we're going to have to investigate that. Because the positive terminal of this capacitor is actually connected to a bolt that holds on the power transformer, we have the unique opportunity of disconnecting this capacitor from the circuit without desoldering anything. And that allowed me to actually hook it up to the capacitor meter. And we see that this 50 microfarad capacitor is showing 75.7, which shows that just starting things off, this capacitor is no good. However, the true tale will be hooking it up to this, since it's disconnected right now, and seeing at what point we start to have leak down. This is rated at 50 volts, and we are going to run 50 volts of DC through it. We're going to start at 3 and see where it starts to leak. So as it turns out, the capacitor tested good up to 50 volts, which I expected. The ones in the box that I tested that went up to 25 volts tested good. The ones went up to 450 obviously didn't test good, but I expected that. The fact that it's measuring 75 microfarads is cause for alarm. But I went back, and I went back to these two 6v6 sockets, because when I looked at the soldering, I noticed that, you know, all the work looked like it was done on this one, and this one stands to look original. And when I looked at the measurements, what I found was the right-hand socket being the good one that we will call, the measurements for the resistor values is pretty close to original. So 1.5 became 1.52. 470 became 4.84. You look at the left values, they really climbed. 470 became 500. 1.5 became 1.7. And right now I have a 6v6 that I just chose at random that I got down here, and it doesn't sit in the socket no matter how you push it. And it seems to be the resistance comes from the right side, right? So I could sort of lean it this way, but I can't lean it that way. And some work was done at some point on this, and this tube does not make a good connection. And I think that was causing a heat issue, and then the heat issue was causing a failure issue. And somebody just kept putting in bigger and bigger wattage resistors to try and compensate for this. And you could see the solder work is clearly not that of Fender. I mean, this is, but I think what we may have to do here at this point is get a new socket for this, and replace the socket and the components. And there's only two components on the socket. It's just two resistors. It's not a big deal. But at this point, I think the socket has seen the better days, and that's going to be the solution for this. So, I mean, the tube doesn't sit in the socket. There really is nothing you can do going forward. We could start contorting pins and heating it up, but really, what are we really doing at that point?